Anyways, 5.1, operations on functions. The good news is the vast majority of this lesson is sort of review. Okay, and when I say it's review, it's because it's stuff you've already done. And there is going to be a tricky part to this, and you're not going to see it today because what's going to happen, everybody get on title? Okay, here's what we're doing today. We are going to take, instead of just one function, we're going to take two. And we're going to do the 4 basic operations with these 2 functions. We're going to add them, subtract them, multiply them, divide them. Okay? That's all we're going to do. Add, subtract, multiply, divide. Now, here's where the challenge is going to come, for lack of better definition. This right-hand side, whenever they do it, split it up like this. Crap, I'm on the wrong part. Here we go. Definitions. Look at these. Addition, subtraction, multiplication, division. The left-hand side, that side is going to be what is given to you. The style it's given to you. F plus g of x. F minus g of x. F times g of x. F divided by g of x. Just as if it was f of x like that. Except now, you're adding these. Okay? Does everybody understand that kind of notation there? Okay, you see, and here's where the tricky part is. You say yeah now, but I'll show you what you guys will all screw up tonight. You watch. Okay? That's why I suggest you go into the right-hand side and you understanding this to this. Instead of doing an f plus g of x, make it f of x like we've always done, plus g of x like we've always done. Same for subtraction, same for multiplication, same for division. Okay? And you'll understand why the notation becomes super important here in a little bit. And I'll show you what the mistake is that happens every single year, every single time, every single class. Okay? Besides that, it's not a terrible process besides for 2 little things. Number one of them is the notation part. Okay, Storner just put them in anywhere. There you go. That's good. Thank you. One's the notation. The second one is division. Okay, because if you look up and down the example, if they say f of x is 2x, g of x is negative x plus 5, that's just combining like terms. 2x plus negative x plus 5 is x plus 5. Combining like terms. Subtraction. 2x minus negative x plus 5. Distribute the negative sign, combine like terms. Multiply the 2. Distribute the 2x through. That's it. The forgetful one, or the one that gets forgotten in the wayside, is the division, or at least not forgotten, but there's a little step to it. If you look over on the definition side of things over here, we say f of x divided by g of x, comma, g of x cannot equal 0. Why?
Because then you divide by 0.
Because then you're dividing by 0, and you cannot divide by 0. So, as we move further and further into the year, we have to start talking about domain and range more and more. Okay? And that starts today. And it comes in play again tomorrow. And basically the rest of the year, is we have to focus on domain and ranges. This is where it starts. This is the one time where it's like the very easiest part of the domain and range, because the only restriction you're going to have is your denominator cannot be 0. Okay? And that's why it's g of x, right? Because it's in the denominator. If these two were flip-flopped in f, it'd be f of x can't be 0. Denominator can't be 0. Okay? So if you look to the right side with the example they give you, you do 2x over negative x plus 5. That's all you do. You literally put one on top of the other. That's the easy part. You got to remember to figure out what your denominator can't be. What number can you not put into that new function that you write that will give you 0 in the denominator? If you do it this one, if you look at it, negative x plus 5, 5 will give you 0. Because it would become negative 5 plus 5, which is 0. So that number, you have to put x cannot equal 5, because that number is not included in your domain. You cannot put that number into the function. Questions so far? Everybody good? Okay, let's go on problems now. Now, sometimes, here's what happens, okay? Given f of x equals x squared minus 4, g of x equals 2x plus 1. Find each function. Indicate any restrictions in the domain or the range. That will only come up on division problems. Okay? Restrictions on domain and range only come up on division problems. All right. How do I want to show you first? Do I want to show you the right way or the wrong way first? Let's show you the right way first, okay? To start out, here's what I would do, okay? You see this notation, and this is the notation it will give you, just like it was over here. F plus G, inside parentheses, X, outside. I would switch it to this notation. F of X plus G of X. Just like that. F of X in this case is what? X squared minus 4. We're adding that to G of X, which is 2x plus, 1. And you add those together, which means you go through and combine your like terms. So x squared plus 2x minus 3. Yes, that's your answer. Okay. That is the right way to do it. Okay? That's perfectly right. Now, you don't, and here's the part where I'm going to get tricky, or it's going to get tricky, or you have to keep it straight in your head. You don't have to go to this notation. You don't have to write that down. I highly suggest it. And here's why. This is very easy. Okay? Nobody's going to stress out over doing x squared minus 4 plus 2x plus 1. You've been doing that for a while now. Okay? Where the stress is going to come and where the vital mistakes are going to be made and where I'm going to take off a lot of points because I hate seeing this because it proves to me that you don't understand function notation is this. Okay? Don't write this. I'm doing it in red because it's wrong. Do the subtraction part. X squared minus 4 minus, we put g in parentheses because you've got to subtract all of g, 2x plus 1. Okay? Here's f, here's g, here's f, here's g. Great. And then we have this big parenthesis, and then we have a parenthesis of x on the outside. That is so wrong. Okay? So wrong. Because this up here is function notation. You're taking the two functions, subtracting them in terms of x. That's what this is talking about. It's not doing f minus g and then multiply by an extra x. Okay? Here's the bad part. You'll do this all right. Distribute the negative through, combine like terms, that's fine. Your answer to my answer will be off by 1 power of x. And on a quiz, on a 3-point problem, you're losing 2 of them. Because you don't understand function notation. This does not mean times by x. This is notation. You got to start understanding the differences. And I'll see it. Someone in here will do it. Hate to say it. Someone will. Okay? I'd put money on it, but I don't have any money, so I'm not going to put money on it. All right? But someone will unfortunately do it wrong. Don't be that one.
Be that guy.
Which is why I go suggesting make sure you, for a while at least, until you get the hang of it, switch your notation up. Okay? And that's going to come into play today and tomorrow. Megan.
So like you said, like if it has like any restrictions, like how's it a division?
That'll be the division. We'll get there. Next slide. Okay? But once you switch your notation, it's just like addition except it's subtraction. So x squared minus 4 minus, here's the little slight trick. Remember these parentheses because you're subtracting all of g, not just the first part of g. You're subtracting both parts of g. So you got to distribute that negative through. before you combine your like terms. So minus 2x minus 1, combine your like terms, x squared minus 2x minus 5. Alright, so change the functions on you. Alright, on purpose, sorry. So now given f of x being x squared plus 7x plus 12, g of x being 3x minus 4, find each function, indicate any restrictions in the domain or the range. So, f times g of x, once again I would just do it, switch your notation to f of x times g of x like that, and then plug each in and get ready for a trinomial times a binomial. So distribute the x squared, so you get 3x cubed minus 4x squared. Do the 7x to give you 21, x squared minus 28. Do the 12, so 36x minus 48. All right, boom, 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 boom. And then your like terms, so 3, they're all going to blow away. I think all right. 3x cubed plus what, 17x squared? I missed an x on my 28. Plus what, 8x? Minus 48. Okay? Good so far. Okay. Last, or at least last one for these functions. So your division, same process, same thing. Switch your notation up real quick. And like I said, you don't have to do this. I suggest doing this for as long as you need to do this, so that way you don't multiply an extra x throughout here. Okay, so you don't have to do that. I don't need to see it, but I highly recommend it for now. All right. Division's pretty simple from the beginning. Okay, it's not like we're eventually going to get to where the divisions are a little more complicated than what we're going to do than what we're doing today. All you literally need to do for the division part, x squared plus 7x plus 12 divided by 3x minus 4. I don't need to see any synthetic division. I don't need to see any factoring to get through a division. All you got to do is put one on top of the other. Okay, that's all you got to do. Put F over top. That's part of your answer. Okay. The other part is this part. Indicate restrictions in your domain or range of the new function, because now you have one. Okay. You don't have any on the first three. Domain is your what? What values? Your x's. Okay. Domain are your x's. Ranges are your y's. Right. You don't have any restrictions of plugging into something you just multiply and add. Multiply and add. Multiply and add, like here, right? You can put any number in these three x's. Nothing's going to funky happen. Something funky will happen here. And the funkiness is whenever this denominator becomes 0. So you need to figure out which number makes that be 0. You can do it two ways. Number one, look at and figure it out. Okay? Some of them will be that way, and I'm okay with that. Okay? These are usually, typically like 2 steps. Okay, or 1 step even, some of them. So you can look at it and just figure it out, and I'm okay with that. The other way is you can go 3x minus 4, and that guy can't be 0. And then you solve it like an equation, but it's a not equals equation. Make sense? So add 4 over. So 3x cannot be 4x cannot equal 4/3. and you need to show both. Okay, you need to show some show just this and not this. Some show just this and not this. I need both. Okay, I know this. Where's my finger? There we are. You rotated on me. There we go. I know this is very basic, very easy. I still need to see it because I need to know you know where they go. Okay. All right. Last ones. F of x equals x minus 1. G of x equals x squared plus 10x plus 24. Find all four functions, four operations. F plus g, f minus g, f times g, f divided by g.
Is there any questions?
All right, add the functions together. X minus 1. Here, I'm not going to show this one, but here's... Okay, x minus 1 plus x squared plus 10x plus 24 ends up being x squared plus 11x plus 23. Everybody good there? Okay. Your subtraction one, remember to make sure that you get the negative to each term of your second function. Okay, not just the first one. Make sure you distribute that negative through. So you need to set it up. X minus 1 minus parentheses x squared plus 10x plus 24. Distribute that negative sign through. Ends up being negative x squared minus 9x minus 25. Okay, everybody good there? Okay, your multiplication one ends up being x minus 1 times x squared plus 10x plus 24. Same way as last time, binomial times trinomial. You guys should know how to do that by now. Ends up being x cubed plus 9x squared minus what, 14x? Is that right?
Plus 14.
Plus 14x? Ah, but dang, yes, plus 14x, my bad. Ah, too much on the backspace. Minus 24, right?
Yeah.
Okay, so there's your multiplication, all right? Now your division. You take your two functions, x minus 1 divided by x squared plus 10x plus 24. You take that denominator. Now that denominator will always be something that you know how to solve. Whether you remember how to solve it or not is up to you. Beginning of the year, I said there were two things you need to remember throughout the year. One was solving equations. What was the other one? Factoring. Factoring, for the love of God, throughout this class does not go away. It's everywhere. And I mean that. I'm not just saying that to make a point every time it comes up. It is in every single chapter. You need to remember how to factor because it comes up every chapter. At least the next 3. Okay? Comes up every time. So here, whenever you have it not equal to 0, pretend it is equal to 0. It's a quadratic equation. We know 3 ways to solve a quadratic equation. Complete the square, quadratic formula, but our favorite one is factoring because it's the fastest. Multiply number of 24, add number of 10, gives you x plus 6, x plus 4, and those two cannot equal 0. Then you can use your product property of 0, whatever the 0 product property, whatever it's called from back in the day, and split it up the same way. X plus 6 cannot equal 0. X plus 4 cannot equal 0, which means x cannot equal, I didn't put a 0 there. X can equal negative 6. X can equal negative 4.
I think you get it right.
That denominator can be anything. It can be a, let me think about this. It can be a linear equation. It can be a quadratic equation. And those quadratics, you have like basically 3 ways to factor. You have your perfect squares, your normal trinomials like this, plus your, I already said difference. Your trinomials with the number in front too, bottoms up. Okay? Those are all in play here. Chances are this won't be a cubic because solving the trinomial part to a difference of cubes is a little challenging. It won't be a 4th power like we did before the semester was up. It'll either be a quadratic or something like that. Okay? There you go.